All right, we also have what we call the inverse reading of the table. Okay, and it might be something like, so here's an example problem, and you don't even need the table to answer this, okay? What is the z-score that corresponds to an area of 0.5? So you should be able to answer this question without any looking at the table, just reasoning, right? What is the z-score that corresponds with an area of 0.5? Okay, so I'm not saying z is equal to 0.5. I'm asking what z gives me an area of 0.5? 0. And the answer is z equal to 0, right? Because if we draw the picture, and if I want the area of 0.5, then I draw right in the middle, and z is equal to 0, okay? So this area is 0.5, and the z that gives me that area is 0. Is that okay? All right, so these questions get written a little bit funny, okay? So this question, okay, can also be written as what z-score corresponds to the 50th percentile. Have you heard that word before, percentile? Okay, so what does it mean to be in the 50th percentile? So 50th percentile means 50% of values are lower. Okay? So essentially we're asking, you know, what is the z where half of the z's are lower? Okay? So that means the area to the left is 50%. Okay? So when it says what z corresponds to the 50th percentile, we're essentially asking what z corresponds to an area of 50% or an area of 0.5. Are there any questions here? All right. So let me change this question to what z-score corresponds to the 30th percentile. Now you don't have to give me an answer, but if I were to draw a picture, okay, so where would I draw my line and how much would I shade in? When we talk about drawing a picture, okay, so step one, okay, what z corresponds to the 30th percentile? What area am I shading in? How much? 30%. 30%, okay, to the left. So am I going to be to the right of 0 or to the left of 0? To the left of 0, okay? So what z corresponds to the 30th percentile means I'm drawing some line over here, and the amount that I have shaded, this area, whatever it is, I don't know exactly what number I have here, but I do know this area is equal to what? 0.30. Okay? And I want to know what is the z that gives me this area. So I'm asking what z gives me area to the left equal to 0.3. Okay? So I just want to make sure everyone's okay with starting at this question and seeing that it translates to this question. because you have to do this before we can start to understand how to use the table in this situation. So what z corresponds to the 30th percentile? This means what z gives me an area to the left that's equal to 0.3. Sound okay? Good? Okay, so I got some head nods. So what we're going to do is we're going to the table, and we know from our picture that we're on the negative side of the table, right? So on the negative side of the table, we're going to look through all of these numbers, and we're going to find the number that's closest to 0.3, okay? Or 0.30000, okay? What's the number that's closest to 0.3? This number, right? 0.3015. This is the number I can find that's closest to 30%. So the number closest to 0.3 in the table is 0.3015. Okay? There's 0.2981, but that 0.3015 is even closer. Okay? What is 0.3015? What does that correspond to? The z-score? Negative 0.52, right? So the corresponding z is equal to negative 0.52. So the question isn't asking, I didn't say z is equal to 30%. I'm saying the area to the left of this z is 30%. Is this picture okay?
No, but why is it to the left, not to the right, like she's saying?
Because the 30th percentile, right? So what is the definition of the 30th percentile? The definition of the 30th percentile means 30% of values are lower. Right? So if somebody's in the, if somebody said, here's your intelligence score, do you want to be above the 50th percentile or below the 50th percentile? Okay. You'd rather be above, right? Because that means, if you're in the 80th percentile, then that means 80% of intelligence scores are lower than yours. But if you're in the 30th percentile of intelligence scores, that means only 30% are lower. So here in the 30th percent, that means only 30% are lower, okay? And if 0 is in the middle, and I'm to the left of 0, am I in the positive values or am I in the negative values? I'm in the negative values, right? Because I'm to the left of 0. So that's why we're on the negative side of the table. Okay? Are we okay with getting z equal to negative 0.52? We're good? Yes, Arturo. How did I get what? 0. Okay. So were you okay with everything I said about the? I want the area to the left being 0.30. Okay. So I go to my z table and I'm looking for the area in the z table that's the closest to 0.3 or 0.3000. And what's the number I find in the table that's closest to that? The number I find closest is 0.3015. The closest number to 0.3 in the table is 0.3015. Is that okay? Okay? So what is the z that corresponds to this area of 0.3015? Well, it's the row negative 0.5, and it's in the column 0.02. Okay? So that means the z is negative 0.52. Okay? Is everybody okay with this? All right. So now we're going to apply these to problems. Okay? Okay. So we're going to say something like this. we will say cows, we'll say the weight of cows follows a normal distribution. What's the average weight of a cow? No. 2,400. That's an adult male bull. Let's see. Let's do female cow. 1,660. Okay. All right. Okay, so we'll say the mean is 1,660 pounds, and okay, and we'll say the standard deviation is 120 pounds. Is this okay? So the mean is 16. So we might say weight in shorthand. I can write something like this to say it comes from a normal distribution, big N. The first number will be the mean, and the second number will be the standard deviation. So I could write the weight of cows follows a normal distribution with the mean is 1,660 and the standard deviation is 120. Okay, we have seen problems kind of like this already, right? And then I ask something like a cow, a particular cow weighs, we'll say 1,800 pounds. Okay, and then I ask something like, what is the Z-score of this cow? Do you guys remember how to do this? It's just like 2 weeks ago. Yes?
Is it 1,800 times 120 plus 1,660?
No. How do we get Z-scores? What is the Z-score? The Z-score is the Z-score is the distance from the mean expressed in standard deviations. Do we remember this? Okay, Z-score is the distance from the mean expressed in standard deviations. So we're going to say Z is equal to what? X minus mu over sigma. So we have, what numbers do I plug in here? 1,800 minus, what am I subtracting? 1,660, and I'm dividing by 120. So what is my Z here? I get 1.1666, etc. 7. Okay? So far, so good. Okay, so this is my answer. What is the Z-score of this cow? 1.166667, or something like that. Okay. I could ask this. All right. Now watch this. All right. Well, first of all, I just want to make sure we're okay with the Z-score stuff. All right. I can't spend time reviewing this because I've already taught Z-scores, but I just want to make sure we're okay. All right. So now we have. I'm going to continue on this question. It's going to say a cow weighs 1,800 pounds. All right. I'm going to ask what percentage of cows weigh less than 1,800 pounds. Okay. Or what is the probability that a cow weighs less than 1,800 pounds? This is equivalent to the same question, right? What is the probability that a cow weighs less 1,800 pounds. Maybe I'll write out the word pounds so it doesn't look like. Okay, is that okay? 1,800 pounds, LBS. These questions are the same. All right, and so now watch what I do, okay? What do we know? The z-score of 1,800 is what? 1.1667, right? So this now becomes, because we know this, we can also turn this into what is the probability that z is less than 1.16667. Okay? So in other words, a cow weighs less than 1,800 pounds. What percentage of cows weighs less than 1,800 pounds? Basically, I find the z-score, which we just did, 1,800 minus 1,660, divide by 120. I get a z-score of 1.16667. And then what I'm going to do, okay, now that I have this and I want what's the probability that z is less than this, I'm going to draw a picture. Okay, in the center I put 0, and over here I'm going to put 1.16667. And I'm going to shade what? To the area to the left or to the right? To the left, right? And then I look this up in the table. Now, here's the important thing. The table only has 2 decimals of precision, so you have to round to 2 decimals. So what is this number rounded to 2 decimals?
1.17.
Yeah, so round to 2 decimals, and we would get z equal to 1.17. So we look this up in the table. Look up 1.17 in the table, and what is the area that we get?
0.8790.
The area is equal to 0.8970.
8790.
Oh, 8790?
Yeah.
1.17, yeah, 8790. Okay, so this is our area. What is the probability that a cow weighs less than 1,800 pounds? 0.8790, or what percent of cows weigh less than 1,800 pounds? 87.9%.
You got 1.17, and then how'd you get to 8.871?
So I look up 1.17 in the z table. So I go to the row 1.1 and the column 0.07, right? And I get 0.8790. Are you okay? Okay. All right. Can we try another problem like this? Sure. Let's try this out. Okay. Okay. So I'm gonna say. So we'll still say cow weight comes from normal distribution, mean weight of 1660, standard deviation of 120. All right. So I'm gonna ask. I'm gonna put up a few questions. What is the probability a cow weighs more than 1,700 pounds? Okay. What percent, or yeah, I'll say what is the probability a cow weighs between 1,500 and 1,700 pounds? Okay, go ahead and try these questions out. Alright, here, just do the first one. Just do the first one and then we'll work through the second one together. So I'll give you guys a couple minutes to work through the first one. So I suggest drawing a picture and then working. Okay. Let's take a look here. Okay. All right. So what is the probability a cow weighs more than 1,700 pounds? The first thing we should do is turn this into a z-score. So what is the z-score corresponding to 1,700 pounds?
0.3
Okay. So we get 40 over 120, and we get 0.33333333, right? Okay. So drawing our picture, I'm going to put 0 right here, and I'm going to go to 0.333, and I want the area to the left or to the right? It says weighs more than 1,700, so I want the area to the right. Okay? So when I look it up in the table, my z has to be what? It has to be rounded off to 2 decimal places. So we look up z equal to 0.33, and what do I get when I look that number up? I get the area to the left from the table is 0.6293, but that's not my answer. This is the area to the left. I want the area, what? To the right. So what do I have to do? 1 minus 0.6293, and that gives me 0.3707. Okay, so what is the probability a cow weighs more than 1,700 pounds? About 37%, 0.3707. Is that okay? Thumbs up? Good, okay. All right, so this question, what's the probability a cow weighs between 1,500 and 1,700 pounds, okay? So what we're going to do is we're going to turn both of these into z-scores, okay? So from above, we know that the z-score for 1,700 is what? 0.33, okay? And what's the z-score for 1,500? So we're going to do z is 1,500 minus 1,660 divided by 120, and I get 160 over 120. That's negative 1.33. Okay, so here I get negative 1.33. Is that okay? All right, and so in my picture, I'm going to put 0 in the middle, and I'm going to put 0.33 over here, and I'm going to put negative 1.33 over here. And the area that I want is the area in between. Is this okay? All right, now how do I get this? Well, I say the way we're going to get this is we're going to do this. So first I'm going to find, oops, that's not what I wanted. So I'm going to find the area to the left here, and then darn it. And then I'm going to subtract off okay. So we're going to find this area minus this piece. And that's how we're going to get the area in between. So we're going to say we're going to do this area minus this area. Okay, and that's going to leave us what's in between. Can you guys see that visually? That if I want this area here, I'm going to find this area to the left and subtract off this piece, and that's going to leave me what's over here. Okay? Visually, are we okay there? Okay? So, star this, you might see something like this. Okay? Weighing between two weights, or two values. You're going to find the area to the left of this one, subtract off the area to the left of the other piece, and you'll be left with the area in between here. So if I take this, everything to the left of 0.33, and I subtract off the area to the left of negative 1.33, I'm left with the area in between. Alright, so how much is to the left of 0.33? 0.6293, right? We looked that up, and we know this area is 0.6293. How much is this area? Negative, if we look up negative 1.33, 0.0918. Okay, so the area to the left of negative 1.33 is 0.0918. Okay, so the area in between this thing is going to be 0.6293 minus 0.0918. 0.6293 minus 0.0918, and I am getting 0.5375. And that is my answer, 0.5375. What is the probability that a cow weighs between 1,500 and 1,700 pounds? 0.5375. Is there a question there?
Oh, no, that's okay.
No?
No, yeah.
I want to make sure we.
I was just wondering, like, what, the 1,500 and then under is negative 1.3.
Yeah, so I'm finding the z-scores. So I'm turning 1,500 into a z-score.
Oh.
Okay? So this is the z-score for 1,500. Z for 1,500 is negative 1.33, and the z-score for 1,700 is 0.33. So in these problems, the very first thing is to turn your measurement, the weight of something, the height of something, some score, into a z-score. And then that lets you look it up in the table. If you don't turn it into a z-score, you can't look it up in the table, because the table only goes from negative 3 point something to 3 point something. So you have to turn them into z-scores, and then you can look it up in the table. Okay? Okay, can I flip to the next slide? No. Okay. I'll give you another minute to catch up on writing. Okay, are we ready? Okay. All right, so let's try an inverse problem, okay? Now, I'm not, on the test, I don't say this is an inverse problem, this is a regular problem, okay? But here, okay, so we're gonna say something like, we're still gonna say cow weight comes from the normal distribution, mean weight of 1660, standard deviation of 120, okay? And we're going to say, what is the weight? So here's just a quick check of our understanding, okay? We don't need any tables or any formulas for this. So I'm going to just say, what is the weight And don't shout out the answer. I want everybody to read this question and think of the answer yourself. So don't shout out the answer. But I'm going to ask, so everybody should think of the answer though. What is the weight of a cow in the 50th percentile? Okay, so think of this answer. Don't shout it out. What is the weight of a cow in the 50th percentile? The only thing we know about cow weights is that the mean is 1660 and the standard deviation is 120. So if we know this, what is the weight of a cow in the 50th percentile? Okay, so what is the answer here? Do we think of an answer? So yeah, so the weight of a cow in the 50th percentile is 1,660 pounds. Okay? Because that is the average weight of cows, and that means, you know, if we look at our normal distribution, so what number goes in the middle? It goes 0 for z-scores, but in terms of cow weights, what other number goes in the middle? 1660, right? So what percentage of cows weigh less than 1660? 50%. So this is the cow, the weight of a cow in the 50th percentile is 1660, or has a z-score of 0. Okay. Is that okay, right? If you're right at the average, you're in the 50th percentile, okay? If you're, okay. So everybody who's average, which is whatever we're talking about, average this or average that, average is right in the middle, okay? If you're average height, you're at the 50th percentile. Half of people are taller than you, half of people are shorter than you. All right, let's try this now, okay? We're going to ask, what is the weight of a cow in the 80th percentile? Okay, so before we even begin to answer this question, a cow in the 80th percentile, is this heavier than most cows or weighs less than most cows? Heavier, right? So that means whatever answer we get should be bigger than 1660. Can we agree on that? Okay, 80th percentile means 80% of cows weigh less than this. So that number has to be bigger than 1660. And these types of just logical checks will help you avoid silly mistakes on tests, okay? Because sometimes people just, they're not being careful, they do something silly and they use the negative rather than the positive or something like that. If you just say, hey, wait a second, 80th percentile, that's got to be bigger than 1660. It's got to be bigger than the mean. And you just say that, then you will avoid some problems. Okay, so let's draw this. Oops. All right, so if I draw this thing, okay, I'm going to put 0 right here, and I'm going to draw a vertical line to the left or to the right? To the right. And that means how much is shaded over here? 0.8, right? So 0.8 is shaded over here. And I want to know what z-score gives me 0.8. What z gives me an area of 0.8, okay? And so what is your answer there? I gotta find, no? Okay. So what z gives an area of 0.8? Okay. So what is the closest value I can find what is the closest area to point 8?
7995.
Yeah, so the closest area to point 8 is 0.7995. That's the closest number I can find. And what is the z that gives me 0.795? 0.7995. Okay, so this z is equal to 0.84. Is this okay with everybody?
Why is it 795?
Okay, so let's look at the table, right? So we're going here, we're going to try to find, we're looking through all of these numbers, we're going to find the number that's closest to 0.8. What's the number that's closest to 0.8? So I got 0.7967, 0.7995, 0.8023. Okay? This is the closest number, 0.7995. This one's farther away from 0.8 than this one is. Okay? So the z that gives me 0.7995 is 0.84. Is that okay? All right. So if my z-score is 0.84, what is the weight that corresponds to a z-score of 0.84? Okay, so now we ask, what weight corresponds to z equal to 0.84? How do we do this? Okay, well, we know z is equal to x minus mu over sigma. Okay, so we can plug in the values we have. We got 0.84 is equal, do we know x?
No.
No. Do we know mu? 1660. Do we know sigma? 120. Okay, so we solve for x, right? And we know how to do this. We get 1660 plus 120 times 0.84. Okay, so that's just algebra. And we do this, 1660 plus 120 times 0.84. And I get 1760.8 is equal to x. So what is the weight of a cow in the 80th percentile? 1,760.8 pounds. Is everyone okay? Yes, question.
It's x minus 1660. Wouldn't it be negative 1660?
So you multiply both sides by 120, and you got 120 times 0.84 is equal to x minus 1660. And then you have to add 1660 to both sides to get rid of it.
Gotcha.
Yeah.
So can you say that again?
We're solving for x. So to solve for x here, so this is just basic algebra. We just multiply both sides by 120. And then once we do that, then we're going to have 120 times 0.84 is equal to x minus 1660. And then we add 1660 to both sides. So we get 1660 plus 120 times 0.84 is equal to x. Okay, so make sure you can do this kind of problem and the other kinds of problems, right? So I'm not going to say this is an inverse problem, this is a non-inverse or regular problem, but you can tell because in the inverse problem it will give you something like the percentile, or it will say, you know, what weight corresponds to this percentage being less or this percentage being more. Okay, and the wording will be something along those lines. And in the other types of problems, it will ask what percentage or what is the probability, okay? In these ones, we're asking what is the weight. So if you're asking the measurement, what is the weight, what is the score, what is the height, those will be inverse problems. If we're asking what is the probability, what is the percentage, those will be regular forward reading problems. All right. Okay. can I move on to the next thing? Shall. All right, and so the last set of problems we're going to cover is the binomial distribution. Okay. So in your reference tables, if you turn the page, you'll see a table that says binomial probabilities. Binomial probabilities, okay? So with the binomial distribution, okay, all binomial problems will have 3 values, okay? And so in this class, we're going to keep it simple. We're going to just say you're going to be we're going to use the table to get our answers. If you took a more advanced statistics class, we would give you formulas that would let you calculate these things out. But in this class, we're just going to use the table to keep it simple. Okay, so this is the easy version of the binomial distribution. Okay, but this is the key part. All binomial problems will have 3 values. Okay, and those 3 values are n, x, and p. Okay. N is equal to the number of trials repeated, I should say repeated trials. X is the quote unquote desired number of quote successes. Okay? Because successes may not necessarily be a good or bad thing. Okay? And P is the probability of a quote unquote success for each trial. Okay, so let me just explain this. So here's an example of a binomial problem. And I think the hardest thing with binomial problems is recognizing that it's a binomial problem. That's the hardest part about binomial problems, is reading a problem and recognizing, hey, this is binomial. Because once you recognize it's binomial, then it's just a matter of finding n, x, and p, and then looking it up in the table. Okay? But the hardest thing about the binomial problems is recognizing that it's a binomial problem. So I'm going to give you an example of a binomial problem, and I'll tell you how we can recognize that it's a binomial problem. Okay? So I'm going to say, I will flip a coin 6 times. Each time I flip it, the probability that it lands heads is 0.5. And I want to know, what is the probability that it lands heads three times? Okay, so I just want to make sure we understand what this question is asking. I'm going to flip the coin 6 times, and I want to know what's the probability that after 6 coin flips, it landed heads 3 times. Okay, and what do you think that answer is? Huh? So do you think is the answer 50%? Why would it be 50%? Right? so if it were 50%, would you take a bet? I would say, I'm thinking it's not going to land heads 3 times, and you say it's going to land heads 3 times. Who do you think would win? Huh? Each coin flip has a 50-50 chance, but I'm flipping it 6 times. Now what could happen at the end of 6 coin flips? I could get heads. Could I get heads 4 times? Yeah. Could I get heads 2 times? Could I get heads 5 times? What about 1 time? Could I get heads all 6 times? Could I get heads all 0 out of the 6 times? Yeah? Okay. And I could also get heads 3 times out of 6, right? And so out of all of those possibilities, okay, I want to know what's the probability that it lands heads 3 times out of 6. Okay? So what do you think that answer is? Well, the answer is you probably don't know. We don't really have an intuitive sense about these things. The answer is it happens about 30% of the time, 31.2% of the time. Now, how do I know this? Okay, well, we're going to read this problem and we're going to identify n, x, and p. Okay, so how many times am I repeating a certain trial? I'm flipping the coin 6 times, so my n is equal to 6. How many successes do I want? I want it to land heads 3 times, so my x is 3. Okay? And what's the probability that it lands heads? Each time I flip it? 0.5. Okay? And so we're going to the table and we're going to look up n is 6, x is 3, and p is 0.5. Is that okay? So from the problem, we've pulled out these numbers. We go to our table. Okay? So we go binomial probabilities and we find n. Okay? And then we're going to go n, 2, 3, 4, 5, 6. Okay? So we find this thing. And once we find n is 6, we're going to go right to the next column, which is our x, and we're going to go to x is 3. Do we see that? Okay? And then we go to the column 0.5, and we have 0.312. So our answer is 0.312. N is 6, x is 3, p is 0.5. What's the probability it lands heads 3 times out of 6? That happens with probability 0.312. Huh? Yeah. So you just figure out n, x, and p, and then you look that number up in the table. Okay, so then somebody asks, what is the probability that it lands heads 4 times? So same question, 4 times. And what is the probability? The probability is equal to, right, we just go to n is 6, x is 4, and p is 0.5, and we get 0.234. All right. Is that good? It's not too bad, right? Okay, so how do we know that this is a binomial problem? Huh? Okay, so the key to a binomial problem is you are repeating a trial a certain number of times. So it might say something like you're going to play the game 4 times, or you're going to do something an n number of times, okay? And then the other key is that you are interested not in the order of what happens, but just in the end result, what happens at the end. Okay, so I'm gonna write 2 problems up on the next page. All right, and we're gonna say, I'll say you play a game of chance. Play a game of chance 3 times. Can't spell here. Okay. All right, 3 times. Okay, and the probability of winning each game, of winning each time you play, is 0.7. Okay. So here's one. I'm going to say, what is the probability you win the first game and lose the other two. Okay, and over here I'm going to ask, what is the probability that you win exactly one time out of the 3 games? Okay. So I'll let you guys write this down, and I just want to point out a few differences between these two questions because they're similar, but they are different. Okay, so what is the probability you win the first game and lose the other 2? This is not a binomial problem because here we care about the order. So this is not binomial. Okay, here the order matters. Okay, what is the probability that you win exactly one time out of the 3 games? This one's binomial. We don't care if the time you win was the first game you play, the second game, or the third game, or whatever game, okay? This one is binomial. This one, the order does not matter, okay? Okay, so to answer this one, what is our n? 3. What is our x? 1. And what's our p? 0.7. Okay, so we're going to look up nxp, 31.7, and what is the answer that we get? Probability is equal to 1.189. Do we see that? N is 3, x is 1, and p is 0.7. And we get 31.7. Probability is 0.189. Is this okay? Good with everybody? Okay, so how do we answer this question? We want to win the first and lose the other 2.
0.7 times 0.3.
Yeah, so we have to go win, then loss, then loss. So this is going to be 0.7 times 0.3 times 0.3. And this is going to be something else. 0.7 times 0.3 times 0.3. 0.063. Okay. So on the test, I'm not going to say, hey, this is binomial. Hey, this one's not. Okay? You're going to have to read this, and you're going to have to say, oh, do we care about the order of things? Yes or no. If you don't care about the order of things and you're just looking for a certain number of outcomes, then it's going to be binomial. If you do care about the order, then it's not binomial. Okay, and so this also helps us with another kind of problem, right? Or not another kind of problem, but what you learned before can also be framed as a binomial. So last week, and also on the quiz, we covered this. And what if I asked, what is the probability of winning at least one game? Okay. So when you did this on the quiz, what we said, winning at least one is the same thing as not winning 0, right? If you don't win 0, then that means you've won at least once. Okay, so we can do this by doing 1 minus the probability of winning 0, and so this means 1 minus lose, 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 which would be 1 minus 0.3 times 0.3 times 0.3. And we would get 1 minus 0.027, which gives me 0.973. Okay. So this part's review, right? We could frame this as a binomial. We could answer it this way, okay, using binomial. Or with binomial, okay, n is 3. Winning at least 1 means x is 1, 2, or 3, right? And p is 0.7. So we could say, I'm going to play the game 3 times. What's the probability that x is 1, or x is 2, or x is 3? Because that's winning at least once. I can win once, twice, or thrice. P is 0.7. Okay, so then we look up n x p. N is 3, x is 1, p is 0.7. So for x equal to 1, what is the probability? We got that to be 0.189. What's the probability that x is 2? 0.441. And what's the probability that x is 3? 0.343. Okay? These are or situations, right? X is 1, or x is 2, or x is 3. But there's also no overlap. You cannot win 3 games at the same time as winning 2 games. Okay? You either won 2, or you won 3, or you won once. Okay? So we're just going to add these. There's no overlap to worry about, to subtract off. And if we do that, 0.189 plus 0.441 plus 0.343 gives me 0.973. So this question can also be answered using the binomial table, and we get the exact same answer, 0.973. Is that neat? I'm sorry? Yeah, I'm adding those 3 numbers, right? Because it's probability of x equal to 1, or probability of x equal to 2, or probability of x equal to 3. Yes, question?
Can you do a problem that does overlap?
With binomials, there's not going to be a situation that overlaps. You can't win. Yeah, I mean, I could do a separate probability problem with overlap and stuff. But yeah, I want to cover this binomial stuff here.
Can I just get
Oh, okay, sure. Hang on a second. Give me a second here.
You're going to post a video of this?
Yes.
This is a lot of writing.
Okay, and you know I've been posting the notes online as well. These lecture slides have been posted as well, right? You guys see that? Okay. Okay, so let's just we'll try a few problems, okay? So we'll try a few drills, practice problems. Okay, so we'll say I don't know. Average weight of hippopotamus. 3,300 pounds. That's a lot. How much does what's the weight of an F-150? Okay, it weighs more than a hippopotamus. I'm gonna weight of a Toyota Camry, more or less than the hippo. Oh, right around the same weight. So the Toyota versus the Hippo. Huh? CRV. Okay, you can look that up. All right. So we'll say Hippo weight. It's such a ridiculous song, right? I want a hippopotamus for Christmas. That thing's gonna smash you, man. You guys never heard of that song? I want a hippopotamus for Christmas. Well, you're gonna start hearing it in like after Halloween. You got 12 days, 11 days. Let's say the standard deviation. I'm making this up. Okay. Oh, I should convert this into kilos for our international friends, where 3,300 means absolutely nothing. 3,300, 1,500 kilos. Okay. Same weight as a Toyota Camry. All right, so I'm going to say, what percent of hippos weigh less than 3,500 pounds? Okay. And then I'm going to ask, what is the weight of a hippo in the 10th percentile? Okay, so go ahead and work on those two problems. I'll pause the video here. Alright, so I'm going to start. We're going to turn 3,500 into a z-score. Okay, so we do 3,500 minus 3,300 divided by 250, and we get 0.8, right? And so now I draw my picture. I got 0 here, and I'm going to go 0.8. And do I want the area to the left or to the right? With less, I want the area to the left. So I look this up. I got z equal to 0.8, and the area that the table gives me is 0.7881, and that is the area I want. Okay? So what percentage of hippos weigh less than 3,500 pounds? 78.81%, right? Because 0.7881 corresponds to 78.81%. Okay, so far so good? Okay, I looked around, a lot of you guys were on the right track here. All right, so over here, I'm going to start here with my picture, and it says, what is the weight of a hippo in the 10th percentile? Okay, so now I'm going to shade over here, and I want this area. What do I want this area to be? I want this piece to be 10%. Okay, so I look through, and I look in the z table. Look for the area closest to 0.10, and I find 0.1003, and this is what? This is z equal to negative 1.28. Okay, so I got z equal to negative 1.28, and that is x minus 3,300 over 250. So I got negative 1.28 times 250 is equal to x minus 3,300. So I add that to both sides, and I got 3,300 plus negative 1.28 times 250. What's too fast? But this is just basic algebra, right?
There's a midterm on this Tuesday.
Where did I get 0.1003? So here I go to the table. I'm trying to find the number in the table that's as close to 0.10 as I can possibly get. Okay, so you have to look through all those numbers. They're in order, so it's not so bad, right? Just like, and the number that you can find that's closest to 0.10 is 0.1003.
Should it be 0.0099?
I don't see a 0.0099. I see 0.0. Oh, 0.00099 would be the closest to 1%, but this is 10%.
Oh, sorry, yeah.
Yeah, okay. So I got,
Steve, give me the answer, you're gonna do the answer.
yeah, so this is 3,300 minus 1.28 times 250, 2980. X is equal to 2,980.
I forgot about that last formula. I got it to negative 1.28.
Yeah, so yeah, and then it's a matter of turning the z-score into the weight, corresponding weight.
All you can see is
Okay.
like you're flipping it
Yes,
back.
you're flipping it back.
Flipping it back.
Okay, so some of you guys are asking how we're getting 0.1003. Okay, so when we draw our picture, we know that our z is it positive or negative? It's negative, right? Because we're less than 50%, we're on the negative side, right? We're at 10%, we know we're less than 0, we're negative. So we're on the negative side and we're looking for a number as close to 0.10. So I'm looking and I'm looking, okay? Now don't get mixed up, right? Because over here, this is close to 1%, but not 10%. This is 1%. What we want is 10%. So I'm going dot, 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 and right here I got 0.1003. That's the number I can find that's closest to 10%. And so this is in the row negative 1.2, and in the column 0.08, z equal to negative 1.28. Okay? All right, so be sure you can do these normal model problems. I'm going to post some practice problems for the normal model,
Yeah, that would be good.
and we'll see you guys next week for the midterm. Come here on time.
We'll
So.
post some additional ones.